Okay. All right. So here we have to make these values a little bit different uh, because here should have we should have some kind of the constraint on how much values we contribute. And initially we were contributing some amount in dollars, and we grew up this contribution with this value. So for until 40, until year 40, we just contribute each year plus $500 more, and this is the amount of money we are contributing. So starting contribution is 138786, and then we add for the first 40 years we add up. Next. Uh, Next thing, we have to find out what are the solver characteristics to make us end up with zero value. So engine balance should be zero. Is engine balance zero in this particular case? Uh, Actually, it is. If this values should be true, true. So this value is approximately zero already. We have found the perfect scheme with without any without any solver actually. Okay, so let's try to find out the values here. So initial contribution should be zero. This is what we have to find. We have to find how much should we initially contribute to make our ending balance equal to zero in the end of 60th year. With given that we will add up each year 500 to our scheme. Okay, so solver set objective. We need to find out the minimum value, of our contribution in the initial as the initial problem, and we're going to change this value as well. This is the single value we have to change, and the constraint will be these values. After year, what to say, after year 40, when we start to withdraw our money, we need to make sure that our ending balance is greater than zero. It should be positive. So that means we have to withdraw something, and we make these constraints more equal to zero. Okay. Hopefully everything should work now, and our problem, yes, it's solved, and the solution is perfect. We find out the exact value which we need to place inside to make our ending balance zero at the year 60. So if we change our perceptions and make ourselves like that, about 150, let's implement the solver to find out the initial value, and is it possible to solver, find the initial value C6, minimum, given that these values should be positive. So cannot find. Let us change a little bit then. Yes, a little bit it can find, then maybe we can find out the tolerance of our solution. Is it possible for us to find out 2000? Yeah, okay. Contribution, let us place 2000 as the initial contribution. Then we're able to change that to maybe 121. Try to find, okay. And I think with the initial contribution of that amount, we will be able to find out the exact value of 150,000. So our solution is not enough, so maybe 4,000 will work. So still cannot. I think we have we are withdrawing too much. Maybe try to find. Still cannot. 135. Is it possible to find? What was the initial value of 2000? Again, linearity conditions. Maybe this will work. Still not. Don't get it why it doesn't work, because it should work with 130. And 120. Conditions are not satisfied. Non-linear conditions. It's really strange. Why not? Okay, let's return to the initial one. Do we have the solution working, or it's just the solver which doesn't work? It worked. 120 with this kind of thing. Linearity condition. Okay, so sometimes it's not really great to implement the solver to solve these problems, because we need to keep up the linearity condition in this problem. We have to find out the exact values here in many periods, and in many periods it's really hard to find the exact values which are satisfiable. So maybe we need to consider the constraints, the single constraint which should be 0 here, but without any conditions on that much cells. So let's add the condition, the single condition equal to 0. Okay, and this works, and let's find out whether it is possible to make those work. And each of these cells should be more equal to 150,000. Let's these cells more equal to 150. Okay, it is not feasible solution, but still we could find something at least. So if we place 4,530, we still can find that this value is 0, and everything is fine. Let's change the same to 150 and solve. Yeah, linearity is not satisfied, so for our last option we need to place only 100,000 to make our thing work. Okay. Okay. So something like that works for different solutions. We have to experiment to find out whether these conditions are satisfiable or not satisfiable. If they are not satisfiable, then next week we will talk about the other options of solver, which are evolutionary solver and nonlinear solver. And with the evolutionary solver, eventually we should solve this kind of problem and not be bounded with the linearity conditions here. All right, so hopefully it was not that hard for you. We just need to experiment and our experiments should be placed within the constraints mostly. We can modify the single constraints on all the column with the different constraints on parts of them. So for here, I can see that the whole condition is not satisfied because of that condition not met. 150,000 withdrawal is not possible because only 100,000 here stays, but still maybe we can once again recalculate. No, we cannot find a feasible solution with the linear kind of problem. It's really interesting to find out these boundary conditions. Sometimes the solver cannot find the solution, and that's normal. You have to try to change the options and change the kind of constraints you place in the solver to understand whether the problem is with the data or with the solver. If the problem is the solver, then as we have mentioned in our first part, the integer condition should be relaxed because it's really hard to find the integer solution. And if not integer solution like this, we have non-integer solutions, we have to try to make our constraints work a little bit different. Maybe it will help us to at least leap to those values. So maybe we have to change the last constraint to not equal to, but maybe change to more equal to 0. Maybe positive value will help. And positive value definitely helps. All conditions are met and the last condition is not met. Maybe it's better for us to understand that this this value is enough for us to live at least 20 years after our retirement on the money that we have placed there, and still 52.5 will be in the end. So depending on our perceptions of what we should obtain, maybe it's not very good just to place 0 at our last variable. Maybe we have to relax the condition. So now we have relaxed the condition from 0, from equal to 0 to more or equal to 0, and this helped us to make the previous years be okay. What I wanted to say, just don't constrain yourself. Try to experiment. Try to find out different ways. Just comment each of this solution you obtained. So I tried relax this constraint. I tried make that constraint different and get this solution. So and you should obtain some kind of a report of what you've done, what you tried, and what results you obtained, and why this or those result is okay and this and those result is not okay. So this is what you have to do in your real life when you encounter the problems like this. All right. So hopefully everything is fine. I'll place those videos on YouTube. You'll have practice. I'll place practice to Moodle within, let's say, maybe 20-30 minutes. It will involve a couple of tasks using the first part of our video when we have several projects and we have to arrange those projects given the resources. And the second problem is by trying to implement the formula and check the formula, which is involved in like the PMT and how can we use that. So Everything is based on the video which we recorded, and hopefully it was helpful to you. Really nice how you dealt with the exam. Hope that you like the marks that I graded. And if no questions, then thanks for coming. See you. See you on Tuesday.